Hey guys, there's two more problems I wanted to do with you before we close this out and you start on your own. This one is number 20 in the book. It's on page 187. So there's this tank that kind of looks like this. I drew it the best I could. It's actually not a prism. It's what we call a triangular. It's not a pyramid. It's a triangular prism where the two bases are the same and it stands up on its side. Like any box really is a prism. It is a rectangular prism. But this is the way it goes. It's 12 feet back this way. It's 3 feet deep. It's 3 feet across the top. Its water is filled in here. The water is green. And that they're telling us that the water is going into this tank at 2 cubic feet per minute. So the water is like actually just pouring into this tank, and the tank is filling up. So if we're identifying our variables, we know that the change in volume as time goes by is 2 cubic feet every minute. So we want a formula to use for this. But we have to notice that this green water prism, its height this way, which we'll call it a height, is always going to be the same. It's always going to be 12. There isn't a point in filling this up where that's not going to fill up the whole bottom. Maybe the first millisecond before any water actually fills up the bottom. But so we need a formula for this, and the formula is the area of the base, where the base is one of these triangles, capital B, times the height, which is this capital H, which is always 12. Now the area of this base is 1/2 base times height, but it's a small b and a small h. It's not the big one, which would go this way, or the big B, which would be the whole triangle side. So when we have this, we have to notice that there's a ratio between the large tank, or the large triangle, and the small one that has water. And if the base and the height this way are 3:3, it's in a 3:3 ratio, so the base and the height of the small one would be b to h equals 3/3. Therefore, 3 dots means therefore, the base is equal to the height if you solve that little equation. And you can stop right there and think about that if you need to. You'll have other ones where it's not a 1-to-1 ratio. It could be a 3:2, and then the base to the height would be 2/3. All depends on what this is. This one happens to be a 3:3 ratio. So what we have is, if the big height, this here, we could say the depth or whatever you want to call it, is always 12. The volume equation is going to be 6 times the base times the height. That's the volume of the water. That's why I made it green. So if we simplify, the volume of the water equation is 6h squared. From there, we want to see, what are they asking us? They say, how is the height changing when the volume's changing that fast? How fast is the height changing when the height is 1 foot? So maybe you're filling this and you want to walk away and say, well, how much time do I have? How fast is that height changing before I have to come back and shut the water off? So what we'll do next is we'll find our derivative, and we'll just take the derivative of this as what 12h times dh dt, because it's implicit differentiation. And then we just plug our variables in. 1 for the h, 12 is there. We want to solve for this, and 2 for the volume. And it turns out that if you simplify this, it's changing about 0.167 feet every single minute. If that makes sense. So that's 12a. You could actually, if you want, you could try 12b, where it asks the question backwards, where they give you how fast the height is changing, and they ask you for the volume. You can try 20b if you want. Next one I want to look at is number 12. Number 12, it's very strange that they put number 12 so early, because they usually do problems in the order of increasing difficulty. But this one is pretty difficult. When I saw it, I said, wow, cool, because what they did is they wanted you to get an area equation for this triangle. Now, I'm not going to go through the whole thing, but I wrote it out for you. I hope you can see the whole thing. I wrote it out for you, and you can look through this and try to think your way through this. Maybe some kind of extra credit on the test for developing a formula for that triangle there. So read 12a and get it. But finally I got down to this point and I had to use a trig identity to do it. Think your way through this one. It's pretty cool. But what we need is we need this equation, because what the question is asking us, it says the angle is increasing by the rate of 1/2 radian per minute, which is right here. It's increasing by 1/2 radian per minute, and they want us to find out how fast is the area changing when the angle is exactly 30 degrees, pi over 6. So this is what they're asking us. Can you guys see this? I hope you can. So what I did is I took my equation and I said to myself, well, this looks like a product rule. However, if we do the product rule, we notice that S in the problem, they say S in this problem is never changing. The angle is just changing how much this angle opens up or closes. So they want to know, how is the area changing as this angle is getting bigger and bigger? But the S never changes. Oh, so then we say to ourselves, remember I said identify which variables are constant. The S is constant. But let me say, let's pretend we forgot that for a minute and we use the product rule. First times the derivative of the second plus the second one times the derivative of the first. And then when we go to plug our variables in, we notice that there is no ds dt because the side S in that triangle is not changing. Take a look at the picture again. The side is not changing. It stays that length, both of these. And they say it's isosceles, so both of these are S's. They're not changing. So therefore, ds dt comes out to be a 0. But if we recognize that beforehand, we could have said right here that, oh, this is a constant, and recognize that this is a constant, and it's as if this were like a 5 sine theta, and just take the derivative of sine theta, which is cosine theta d theta dt. Now we're ready to plug our variables in. We put theta, pi over 6 in for theta, right there. This told us it was 0.5. S is a constant, so if S is a constant, I don't know if you can see this statement that I wrote here. If S is constant and it's unknown, then, this should say then our answer will be in terms of S. So we're going to have an S in our final answer. So the 0.5 is a quarter. Cosine of pi over 6 is square root of 3 over 2. So our answer is just going to be this. So this angle changes, the area changes differently depending on how big that side is, which makes sense. The bigger the side, the area is going to change differently. So good luck, try those problems, and send me an email if you have trouble, and we'll have our test on Monday, and also I'll do a chat on Sunday late afternoon, I guess, early evening, late afternoon. I'll send you a link for that. All right, have a good night. Bye-bye.